let's see here. Tomorrow mission 4 is due, and we have Math Battle 4. And then Wednesday we review. And then Thursday you got your test 4. Friday, we won't be here. So we'll take Friday off, because by then you guys need time to work on your engineering projects for sure. Just guessing. And then what happens next week? Well, then Monday and Tuesday I think I have both devoted for the final battle, which is a math battle but comprehensive for the course. So that should help you review for the final. And that, I think that's it. So, yeah. Question? Yeah.
Are you taking questions right now?
Yeah, I'm taking questions. Haley?
So on the graph with the
Haley?
when you're converting from polar to Cartesian, my tutor says that you go from like you write the Cartesian graph first and then you go to polar.
He's wrong?
And I have no clue.
I mean,
myself, so I just wondered.
I mean, I don't know how to say it more. I mean, like, no, because if you could graph the Cartesian graph first, there would hardly be a point in doing the polar one. So, yeah, well, sorry about that. So what was it? 1 plus 3 cosine theta. Is that right? All right. So to start with, just make a graph. Theta this way, r this way. All right, and you know, a lot of times you can get away with 2 pi. So cosine, let's see here, this is shifted 1, right? So I'll make this one unit right here, okay? So graphically, what you're doing is you're taking the graph of cosine, you're shifting it up 1 and stretching it out by 3, right? So it starts out at 4, right? And then when you're to pi, you're to 1 minus 3, which is minus 2, so it's something like here. And then here you're back up at 4 again. So this graph would look something like that, right? And you can track back here like this too, right? So essentially there are 2 things going on. The one is this piece right here, right? And so if we translate that, so this is what I was talking about. This is the r theta graph.
That's the r theta.
R theta graph. Yeah, theta r. Theta r. No, this is
I just thought that
Cartesian refers to x and well. I mean, that's fine.
and y.
X and y is Cartesian. Yeah.
So the Cartesian is the one with the loop in it.
Yes. This is true. Cartesian is x and y coordinates. Yes. Okay. I mean, well, anyway. If you have both, then you're going to get full credit. You know, I mean, like, it doesn't really matter too much which one you're calling which, unless I ask for just one of them, I guess. Then we could have a problem. But anyway, so the real question is, where does this happen, right? What are these points here? And that's going to happen when 0 is equal to 1 plus 3 cos theta, which is theta is equal to inverse cosine of like minus 1 over 3, whatever that works out to, right? So, well, let me call this theta 1, and whatever that is, let me just graph some. So like here is theta 1, and here is minus theta 1. It's fairly clear that those are symmetric for that loop, right? And the maximum radius happens right here, which is what? 4, right? 4 at theta equal to 0. So if I did this exactly right, you could just translate this distance to that distance, you know. But anyway, something like that. Theta 1's past pi over 2? Oh, yes, thank you. My bad. Duh. Yeah, I should see that. Good grief. This is what comes from trying to shortcut. Thank you, Sam. That's helpful. Now, if that's the case, I think, yeah, this one's also past minus pi over 2. Then, of course, right, there's that symmetry, right? All right, so great. So that one outer loop is something like, and I'm going to make it, I'm not going to do these to scale, just to make it bigger for you guys. So it's something like like that, roughly speaking. This is this piece. Now I'll go in a different color for the other one. This piece right here, right? That is corresponding to, so this is 2 pi from there, right? So these are those same rays, but here r is negative, right? Which flips it over. Let's see here. Well, it would be over here, right? But it flips over because r is negative, and what's the smallest is what? This is what? Minus 2. So that's kind of in the half here. So it's not too little, but it's something like this, right? So I asked you guys to find the area of this character in here, right? So I think what you'd want to do would be to integrate. You'd have to integrate 1/2, 1 plus 3 cosine theta quantity squared d theta. And the bounds that you would want would be from like here, right? Let me call that theta 1, over to here, let's call it theta 2, So that would be the area.
Could you double it and go from 0 to theta 2?
Sure. Yeah, the symmetry allows for that as well. But anyway, you guys have other questions about your homework though? So I don't want to use all the time up on this one. Yep.
From 177, it's like this 3 R's, like this is one that's cosine theta.
Is this from the book or is it from
No, it's from the YouTube button.
one of my custom creations? Let's see here. You said 177?
Yeah.
Calculate the area of intersection of the areas bounded by r equals. Oh, yeah. So what was your question about it? Just how to do it, or?
Yeah.
So the way I would do it, and you said those were circles?
Yeah.
So you figured that out. That's good. The way I would figure that out would be, there's 2 different ways, right? The one way would be just to, graph in the r theta plane and just kind of translate them to circles. Maybe I should do that since we haven't. Well, maybe I'll just let you tell me where the circles are. How about that? Oh, you don't know? Oh, okay. Well, listen, so I'll do it. It's fine. It's fine. It's all good. So sine looks like this, right? So there's pi. There's 2 pi. I think this is just a duplication of the same thing again. And then the cosine, 2 cosines like this, right? Roughly speaking. So if I graph those, what are we looking at? R equals, so it starts out at 0. Starts out at 0. When you get to pi over 2, you're at a radius 2, right? So we start at 0, we're up to radius 2, and then when we get to pi, we're back to 0 again. At pi over 4, we're like out here. So the sine is basically this circle, right? The cosine, same story, well, kind of the same story, but we start out at 2. Oh man, I feel like. So we start out at radius 2, which is not the radius. The circle is radius 1, right? But it's we start at this point here. As you go to theta equal to pi over 2, you're to radius 2. Excuse me, you're to radius 0. I'm a dummy, like that. So anyway, it's something like this, right? And then what's the other circle involved? R equals 1, which is got this point and this point, right? Roughly speaking. So you're trying to find the area that's bounded by all three. Where is that? This middle one right here, right? So got to be careful with this one because it's a little bit slippery. Let me blow it up. Focus our attention just on the part. Trouble trying to think of. That is not quite right. If I had a compass, we'd do better here. Oh my. Okay, fine. Yeah, that's fine. That's fine. Okay, that's fine. The black one is the one I was. This one's. All right. So if you look at this region, right? There's different cases you got to think about. See, because if you draw a radial line from the origin out, you got these two kind of, let's call that theta 1, theta 2, right? The story's different. There's three different stories to tell here, right? You have 0, 0 less than theta, less than or equal to theta 1. You have theta 1 less than or equal to theta, less than or equal to theta 2. And you have theta 2 less than or equal to theta, less than or equal to pi over 2. These are the three regions to think about for the area we're trying to bound. Yeah? So we have to find those angles and break it up and treat it as such, because the inner radius and the outer radius is different in these three different cases. I mean, the integral is, I'll do one of them for you. So like this area right here, right? This one I can calculate without much work. This area is what? It's just theta 2, theta 2 minus theta 1, right? Why? Because you're inside the unit circle, right? So r times the change in theta is the angle of the sector. Yeah.
Wouldn't it just be easier to integrate from 0 to...
I got to divide by 2, by the way. What's that? Yeah.
From 0 to pi over 6 with the top. Pi over 6 is where r equals 1 and r equals 2 cosine theta b. 0 to pi over 6 minus...
Integrate what from 0 to pi over 6?
r equals 2 cosine theta from 0 to pi over 6. And then
Whoa.
subtract that.
Just a second here. I need to label things. So this one, the blue one is what? It's the 2 cosine theta?
No, the red is 2 cosine theta. Blue is r equals 1. Yeah. blue
Oh,
is-
okay. R equals 1. Thank you.
Yeah.
All right. So we were both wrong. Let's see here. Good. The black is what?
Black is sine r equals 2 sine.
Okay. And the red is, what do you say? I mean, I said,
R equals 2 cosine.
okay. So you were telling me to do what?
I'm saying integrate the area under the curve.
And you said this is pi over 6.
No, I'm saying the intersection point between r equals 1
Uh-huh.
and r equals 2 cosine theta is pi over 6.
Oh,
Is a distance of pi over 6 away from the origin. I'm thinking about this in terms of the distance of not arc length, but Cartesian. Basically, I'm saying integrate from.
but this is actually pi over 6 though.
Okay.
That angle. I mean, that's because it's on the 2 sine theta. So like sine theta is sine of pi over 6 is 1/2. And
Right. So that's pi over 6. Then theta 2 is going to be pi over 2 minus pi over 6. So integrate from 0.
Also known as pi over 3, yeah.
Yeah, thank you. Integrate from 0 to pi over 3 the area under the curve of r equals 2 cosine theta, and then subtract the area under the curve of r equals 2 sine theta, and then add the area under the curve r equals 1 theta from pi over 3 to pi over 6, and subtract the area under the curve from r equals 2 sine theta from pi over 3 to pi over 6.
Could you repeat that?
Yeah, basically what I'm saying is just take the first one from 0 to pi over 3, integrate under the red line, subtract the area under the black line, and then integrate the area under the black and subtract the area under the black line.
Would piecewise?
It could be
Yeah,
easier to integrate
piecewise.
the black one up to pi over 6, and then halfway up the
Yeah.
other one, and then just double.
Yes, I agree.
That's what I did.
I'm thinking about this in terms of probably one math calculator. If that makes sense.
So, maybe. But what I'm saying is that, I mean, I'm not disputing that there are other ways to think of it, no doubt. But the inside, between the theta 1 and theta 2 is easy. We can just do 1/2 the change in theta, because that's just a sector of the inner circle. And then to get this slice right here, right, this right here, that area going, that's this one, and that we would get from the integral from 0 to pi over 6 of 1/2 the, let's see here, the outside radius here is the black one, so it's 1/2 2 sine theta quantity squared, d theta. And the inside radius is 0 here, right? And then by the symmetry of the problem, you could just say that this is the same, right? So you could just take this integral, double it, and add it to that. That would give you the area. That's how I do it. But yes, you could subtract things and see it in terms of an analog to, like, difference of areas. This kind of problem, there might be like 4 or 5 different legitimate ways to do it. So if I take points off in your test because you didn't do it the way I found natural, and you made like a arithmetic mistake somewhere in there, you'll have to come and argue your points back for me afterwards, and that's fine. Other questions? Yes, sir.
Are you planning to have the test back by our exam? Or is that on Facebook? Like the test board?
That'd be great.
I mean, I would think so. Let me see here. As a general point of order, I always try to turn back, like, the last test before the final. That begs the question: when is our final exam?
Thursday, next Thursday.
See, you shouldn't be able to answer that unless I've told you, because there's 2 possible times, right?
Well, we're operating the assumption that you're going to do it at the earliest possible time.
I would do it at the earliest possible time. Why would I do that?
So that we can study for them like we can and study for other stuff after the exams.
It purposefully changes to choose.
I would do it as late as possible, generally speaking. Let's see here. Let's see here. Let's see here. This is spring 23, right? And this class meets when?
Start at 9:20 and 9:40.
Ooh, 8 a.m. to 10 a.m. on Thursday? That sounds horrible. Yeah, I don't think we're doing that.
I think you should just give us all like a 90 on the final.
Let's see, what's the other choice? Oh, Friday. Yeah, it would be Friday 1 to 3.
75 on the final. No one
Yeah, because we have Tuesday, Thursday, 9:45 a.m. It's got a Friday 1 to 3 p.m. slot. So I would go with that one. Friday, May 5th, 1 to 3 p.m. I will write it down. Final. Friday, May 5th, 1 to 3 p.m.
Is there a final during that block at all, or no?
Yeah, I mean, that's the officially scheduled, that's for the 9:45 class, Tuesday, Thursday class. It meets 1 to 3 p.m. So you will not have another final at that time because you're in this class at that time. Yes, sir.
So the 0 to pi to 6, 1/2 sine squared, does that just give you the little area from,
Just this piece right here.
yes, sir. And then you would go pi to 6, pi over 3,
I'm saying by symmetry, this is actually equal to the integral from pi over 3 to pi over 2 of 1/2 of 2 cosine theta quantity squared d theta, which would naturally be the area up in here, this little sliver.
how is that great?
By symmetry, I can see it.
Okay.
So I would say calculate one of them, don't do both, you know?
So you have to, you just calculate the pi over, the 0 to pi over 6, that integral, and then
Just double it. I would just double that
double that.
and add it to the area of the big green, the wedge, which, I mean, this would be the integral of the green one, integral from, pi over 6 to pi over 3 of 1/2 times 1 squared d theta, right?
Yes, sir.
But that is exactly what I wrote here.
And how
Yeah.
did you determine what the intercept at? How do you,
You guys told me.
okay, what if we didn't tell you how it determined?
How would you figure it out? I mean, that's a deeply personal question. I don't know. I mean, but
How would you figure it out?
so you set these equal.
You just go to
Look where does so it's where does the blue curve meet the black curve, right? Where the blue curve meets the black curve is where 1 is equal to 2 sine theta, which gives you sine theta is 1/2, which is pi over 6. To get the red equals to the blue, you want 2 cosine theta equals to 1.
Okay.
That's where cosine theta is equal to 1/2. The solution to that is pi over 3.
Yes, sir.
These things we should actually know without a calculator. Yeah.
Other than whatever they said, can you split, could you do 2 integrals where you split between pi over 3? So it's like integral 0 to pi over 3, and then one of them is pi over 3 pi over 6, and then add them. What's the difference? Yes. Okay, you just have to subtract the area. Sick.
Possibly. We should move on to other problems because otherwise we'll just talk about this one today. But so the final exam clear, by the way? Yeah. In here, yeah. Why people? Did you guys ever have a final that was not in the room that you took the class in? Once? Oh. What was it though?
We had breakout. So we
English, you had breakout sessions? That sounds horrible.
What room is it?
Was your final exam like a chair of circles? Did you have to talk about your feelings? I mean, like what happened? No? Okay. Yeah.
So in problem 134, let's just do it the position of the particle, but the position of the particle is given where x is equal to 3 sine t instead of cosine t, and y is equal to 2 cosine t, if that makes sense.
Yeah.
So how would that affect?
It might make it go clockwise versus counterclockwise.
Okay.
Where's my solution? I worked this problem yesterday and I cannot find my stupid solution. Yeah. And Sam is right. That one, be careful. It doesn't start where you think it might. It's modified. Problem what?
it's 130. So, I mean, where you plug it, you put it back into, where you wrangle it back into the calculator, the circle, it's just like,
So problem 134, you've got an ellipse and you've got a circle that's not centered at the origin. So that's the easiest way to graph those. Graph it as an ellipse and a circle. You can see there's 2 points of intersection. And for part B, there is a point of collision, whereas for part C, I got no collision. Mm-hmm.
There's a problem where you have to find the equation of tangent line when it's just r.
I mean, we could do one of those.
It's like 168.
168. I mean, that's definitely a possible problem. Are you wondering how to do it, or okay? So let's suppose we've got, you know, like r is equal to, I don't know, 3 cosine squared theta plus the sine of 6 theta. Find equation of tangent line when theta equals to, oh, I don't know, 5 or 6. That should be interesting. So what I would do is I would look at y is equal to, you know, r cosine theta. X is equal, y is r cosine theta. What's wrong with me? Y is equal to r sine theta, right? So specifically here, that's 3 cosine squared theta plus sine of 6 theta times the cosine of theta. And y is 3 cosine squared theta plus the sine of 6 theta times the sine of theta, right? So once I know those, I can calculate dx d theta, and I can calculate dy d theta. What do those work out to? Well, kind of a mess, but looks like I got a minus sine theta times 3 cosine squared theta. Why didn't I make this simpler? Oh well, it's too late. 6 theta plus 3 cosine squared theta plus the sine of 6 theta cosine theta. So this is product rule. And the other one, I get myself a cosine theta times the 3 cosine squared theta plus, you know, I could save a lot of writing by writing this instead of all this mess. I could write it as r, right? But anyway, 3 cosine squared theta plus, oh man, my bad. I was supposed to differentiate. I was supposed to differentiate this here, right? The derivative of r with respect to theta. So that gives me a minus 6 sine theta cosine theta rats plus 6 cosine 6 theta cosine theta, and likewise here minus 6 sine theta cosine theta plus 6 cosine 6 theta times the sine of theta. So the pattern here, you could write this more cleanly, right? What we're looking at here is like minus sine theta times r, right? Plus cosine theta times dr d theta. That's what's going on here. So I don't know. What I'm trying to say is it might be more efficient to just calculate the derivative with respect to theta of r, know that value, and then use it. Yes, sir.
168 is the circle, and that's the r point of the circle, so it's pretty obvious what the tangent line is if you just grab it quickly.
So is that 168, is that the one that's like r squared minus 3r plus 2 equal to 0 or something? Yeah, this one doesn't work with this method. So that's actually a problem of a different type. This is not a, well, so this is r minus 2 times r minus 1 equal to 0. So it's actually a pair of circles. Yeah.
And so it says it wants to find the tangent line of the point at 2, 0. So wouldn't this be like a straight line? So what? Yeah, 2. So x equals 2.
Yeah, x equals 2 is it. Mm-hmm. Yeah, so that one's easier. The problem, this one on the other hand, you know, I can't do that. And my slope would be what? dy dx equals to dy d theta over dx d theta, right? And I'd put in theta equals to pi over 6, right? Yeah. I put in theta equal to pi over 6 into these formulas. I figure out what that is. That gives me the slope. And then I still have to figure out the point of tangency. Where's the point of tangency? I have to put pi over 6 up into the formula, right? So like, this gives me the slope. And now where it's at, you know, r equals to 3 cosine of, what's cosine of pi over 6? It's 1/2. So 1/2 squared is 1/4. This is 3/4. R equals to 3/4. So the point of tangency 3/4 times the cosine of pi over 6, which is we just said root 3 over 2, comma 3/4 sine of pi over 6, which is 1/2. So if this, I'm going to call the slope m for the sake of brevity here, and that would give me like 3 root 3 over 8, 3 over 8. My equation would be y equals 3/8 plus that slope m times x minus 3 root 3 over 8. But yes, we don't want to take this approach for that problem, because this problem is much easier to solve by direct geometric reasoning, because this tangent line to the circle where it's vertical is clearly just a vertical line, x equals to 2. Yep.
Does that equation r squared minus a equals 2 two circles, or just one that you multiply?
Gives you 2 circles. It's got the circle. It's got the unit circle and the radius 2 circle. But there's only one tangent line at 2, 0. Oh, I'm sorry. We seem to be out of time.
You are forgiven.
So mission 4 is due tomorrow. Very exciting, yes. Thanks.